we've got evolving battery parameters. And if we look at some of these, we highlight some of the areas that are changing. We've alluded to some of these, but take a little closer look at them here. So we've got product changes. So I look at two different sides of this. We've got the things that are happening on the product that are going to affect us, and then we have the things that are happening in testing in terms of how we prove what it is that we built is good and we should ship it to the end user. So the chemistry, lots of activity there. Sometimes this may not have such a radical effect in terms of what we're doing in the production testing, and yet if you break down the production testing across the realms, it may be that there's certain pockets this hit. Maybe this hits up earlier in the process than it does downstream as these modules build and evolve. Something to think about with respect to the baseline chemistries that you're using. Packaging is something that is evolving rapidly. And once again, it comes to your end application in terms of what it looks like, in terms of what the modularity is within your system, how big it is, what environment it's going in at the end. And the interconnections are a big thing with that as well, in terms of eventually all of these need to be plugged in to be charged and need to have a load on them to discharge. And what is that? How is that hooked up? How is that terminated? Is it permanent? Is it something that comes and goes? Are there portions that are permanent, portions that come and go? So a little variety there. What is the product we're testing doing? What do we need to do in testing to ensure that's all going to work for the situation that it's living in? Monitoring is a real big area because this is where we have some intelligence. So once we get up past a battery cell and we start to string a few of them together or weld a whole thousands of them together, we start putting some intelligence on these parts. And we do that for a variety of different reasons. Some of it is so we can know status of the part. Some of it is to monitor for issues with the part. Some of it is to preserve and maintain the overall life and performance history of the part. And so that's continuing to change as well. Lots of change going on here. Some of that is buried in a lot of that actually is buried in the software, and how do you handle and respond to all of that? You get a plethora of data, and what do you do with it? What do we do with it in test? How do we use it? How do we not use it? And of course, safety. Lithium has its own unique characteristics, thermal-wise. Other battery chemistries perhaps do not. But at any rate, the very act of charging and discharging across all chemistries seems to create heat. And what do we do with that heat? How do we manage it? The second side of the safety has to do with safety for human beings. So most of these parts have voltages and currents that are quite hazardous to human people. And how do we protect people from that? How do we protect our first responders when they get on site, be it to a battery fire or a vehicle that's sitting there with a battery in it that can cause serious damage or death to a person? So we have safety circuits in there, and those are also changing, and those standards are evolving. So we look at testing itself. There's a few things that we kind of have. They're kind of de facto standards that we find in the industry. We've got the state of charge, and this is a big one. You know, how much current is in the battery? How much power can it deliver? How much is remaining? And so that one gets tracked a lot, and everybody kind of looks at that, uses that in different fashions. The state of health is a little more nebulous and a little bit harder to define. It's more some of the monitoring we were talking about with respect to the safety and the monitoring of the individual cells themselves. In terms of, do I have certain cells that are degrading faster than others? What is the expected lifetime of this? What can I use of that data that might help me determine what the expected lifetime is? And so there's a set of tests for that. Leak tests, most of these, we find two different types of leak tests that occur in general. We find that we leak test coolant circuits where we're using a liquid of some form, or a fluid, I should say, of some form, in order to maintain a moderate temperature in the batteries. Additionally, we also have the enclosure that the batteries might be placed into in order to determine that they will not off-gas out, or more importantly, even to take things in ingress. For example, if the battery to be plunged into water, what happens? How long can it handle that? And then last or not least, and this gets into more what people typically tend to think about for battery testing, is the charging and discharging. And this gets down into what voltages and what currents do I put into the battery, and what information do I get out of that when I do it. So it kind of tells us a little bit about what we have to do. These things are all changing. This presents the shorter time frames present some difficulties for us in terms of what we're doing on these parameters. And the shorter time frames sometimes mean adapting laboratory and design validation methodologies into high volume production processes, because you haven't figured out exactly how you can test this efficiently in a production environment, or perhaps what are the key parameters I really need to test in a production environment versus what's done in order to prove the things that you want to prove back at a product design point. And we see some issues with this in testing today. We find that those tend to shake themselves out over time. Once again, that goes back to the traditional way of doing these things, and you might have had the time up front to do that. Maybe now you have to go into production with what you know and be able to scale back to something that is what you need in order to prove that you built these correctly. Sometimes we find some difficulty in separating product design validation parameters from production testing parameters. And it gets into the same thing in terms of what's important at the end. Sometimes you find out that the things that they were doing in the laboratory are very important. You need to do those in production. But how do I put laboratory equipment or laboratory equipment measurement capability into a high volume industrial application? Overshadowing all of this, of course, is that potential for change. And that's the thing we're looking to try and deal with and handle, and be able to have a basis that we can go forward and be successful in terms of what we're doing. This is what we have to do in order to handle our testing.